Hi, I'm John Everett with Zurn Industries. Today we're going to show you folks how to set up a ZW209BP. This particular valve is an automatic control valve of the pressure reducing variety, but having the BP option means it's also equipped with a low flow bypass. Pilot operated valves such as the ZW209 have minimum continuous flow characteristics. So therefore, if you fall below that minimum flow, we want to have some form of a low flow bypass to give water to the building in the event that the service needs that flow rate under the minimum continuous flow rate of the big valve. So what we've got is we've got a valve set up out in the laboratory. We're going to show you how to commission that valve, kind of give you a real world idea of what it's like to set one of these valves up in the field. So if you'll come along with us, we'll head out into the engineering lab and we'll commission that ZW209BP. In this sequence, we've got a ZW209BPG set up in the lab. This is a ZW209 equipped with a low flow bypass. Now the low flow bypass on this type of valve is excellent for applications where we have a very low flow at night. Say for example we have some industrial process and we're flowing high flow rates during the day, but in the evening we may have a janitor come in and turn on a mop basin. The low flow bypass is on the opposite side of the valve, and it's just to handle those low flow rates from 0 to 10 GPM. Now right now this valve has already been pressurized. We're going through the procedures of opening up the plug on the top of the bonnet, and we're going to crack various fittings within the tubing to relieve all air within the bonnet chamber. And if we get air above the diaphragm, it makes the valve very spongy. It doesn't want to react like it's supposed to, so it's imperative that you bleed all of the air out when you're commissioning the valve. We're cracking a number of tubing fittings. Again, we just want to crack those until we get good clean water coming out with no aeration. Once again, air makes the valve very spongy, gives us reactions that we don't really want or expect. Pulsation, shaking, etc. So get all the air out of the valve by loosening your tubing fittings at the highest point and also the plug in the center of the bonnet. Now we're going to go ahead and tighten off the plug, tighten off all those various fittings, and we'll go ahead and set the main portion of the valve. Now with the ZW209BP, what we want to do is set the main valve under flow. It has to be flowing greater than its minimum continuous flow. And in the case of this 4-inch ZW209BPG, its minimum continuous flow rate is 50 gallons a minute. Once we get that valve set to 5 psi below our desired static set pressure, we'll raise the pressure 5 psi by adjusting the small bypass on the opposite side. We're taking a moment here just to double check the setting of our opening and closing speed controls. In the case of a PRV, they're typically equipped through 3-inch in size with an opening speed control and generally not with a closing, but I wanted you to be able to see both of them. So what we'll typically do is with our opening speed control, we'll start at 3 turns fully open from seated. In the case of a closing speed control, I'm going to leave it wide open. Generally speaking, we want a PRV to close fairly fast because we don't want to send any surges downstream if we have a sudden stoppage of water flow. In the case of a in the case of an opening speed control, it generally 3 turns open. That will be pinched back enough so that we won't get surging with the valve opening too quickly. Now we've gone downstream and we've started to induce a flow, and I'm going to adjust the pilot valve. And the secret of adjusting this is do things fairly slowly. Give the pilot a little turn once you hear flow moving through the valve. Give it a second or two to catch up. Right now I'm just moving the pilot towards the open position so that we can induce a flow through the valve, the main valve itself. And again, with a direct acting PRV, we'll generally adjust them fairly quick. We're doing it in a static condition, but with a pilot operated valve and being done in a dynamic situation, give that gauge, or rather give the pressure reducing valve a little turn, let the valve catch up. Give it another turn, let the valve catch up. Fairly slow. So right now we're going to start to thread the bolt in on the pilot valve and begin watching our downstream pressure. I've got about 70 coming into the valve. We wanted to set it at approximately 50 pounds statically. So what I'll do is I'll get the flowing pressure down around 45 psi. And once I get to that point, I can lock him down right there. Now once we get the flowing pressure set, we can go ahead and stop our flow through the valve. That's by shutting off a downstream valve. Again, when we set our bypass valve, we want it to be done statically. So I've said it a few times, but I shall say it again. The main valve itself, the ZW209, should be set while it's under flow. And we want to do that at a flow rate greater than 50 gallons per minute. Now we've let the pressure jump back and forth on the downstream side. You can see a little bit of pulsation there, getting the flow rate. I wanted to get it set again, 5 psi below my static set pressure. Once I do, I can go ahead and lock the adjustment nut down. I've gone ahead and I've opened up the bypass valve. Now there's a ball valve on the inlet and outlet of that low flow bypass. Right now I'm just going to bring the pressure up. There you go. You can see I just gone ahead and I've opened up my low flow bypass. I had to back the adjustment bolt off because I didn't want it to be too high. Both the inlet and outlet ball valves to the low flow bypass have been opened. And now I'm going to begin watching my pressure gauge, and I'm going to just go ahead and screw the adjustment bolt in on that low flow bypass until the pressure gauge rises 5 psi above where I was at when I was flowing. And the underlying principle here is when we have say a janitor at night in this industrial complex, he should be able to draw anywhere from 1 to 10 gallons a minute through that low flow bypass. Then the next day when we fire the facility up and we've got high flows, the big valve itself will flow. Now you can see by my description here that there will be what we would call a dead zone in between that flow rate of 10 GPM, which is the max for the bypass, and then the 50 GPM, which would be the min for the main valve. That may require an additional valve in the system. On the back side of this, you can see the large brass bell of an 1.5-inch valve that I had installed in there. And in those cases where we do anticipate on flowing from 0 all the way up to the maximum flow rate of the main valve itself, I would set the main valve at 10 psi below my desired static pressure. The intermediate valve with the bronze bell on it, I would set that 5 psi above that value. And lastly, the small bypass on the backside, I would set 5 psi above my 1.5-inch valve. That way I would be able to operate from a 0 flow rate all the way up to the maximum rated flow of the valve. And that's to the maximum rated flow of the ZW209. So the sequence would be the low flow bypass would open first. When it's flowing enough water to exhibit a 5-pound fall off, the bronze valve would open. And when it's flowing enough to where it reaches that 5-pound fall off, lastly the large ZW209 will open. And this will be a very seamless way to get full flow, again from 0 GPM all the way up to the rated flow of the ZW209. Seamless, smooth, very little pressure drop. So in watching this sequence, I hope that we've helped you out a little bit and given you a good idea of what to do. But if it doesn't really ring true for you, don't hesitate to call us at Zurn Wilkins. That's what we're here for. We want to help you folks put this valve in, get it commissioned correctly, and have it be a trouble-free product for years and years for you. So again, if you have questions for us, shoot us an email at zurn.com or get on the phone and call Zurn Wilkins. We're more than happy to talk to you folks.
Thank you for watching. For more information, please subscribe to our One Zurn YouTube channel. Call our customer care center at 1-855-1-ZURN and visit us at zurn.com.